Our oceans are vast and mysterious. They hold countless secrets waiting to be discovered. We are constantly making new and exciting discoveries. These discoveries remind us how much we still have to learn about the underwater world and its wonders. Imagine the excitement of scientists when they stumbled upon something truly extraordinary beneath the waves, hidden for centuries. In the depths of the Pacific Ocean, where sunlight barely penetrates and the pressure is immense, a team of marine biologists embarked on a groundbreaking research expedition. They were using a remotely operated vehicle, or ROV, a sophisticated piece of technology designed to withstand the harsh conditions of the deep sea. Their mission was to explore a hydrothermal vent field, a place where the Earth's geothermal energy escapes through fissures in the ocean floor, releasing superheated water rich in minerals. These vents are often teeming with unusual life forms, adapted to survive in extreme conditions that would be inhospitable to most other organisms. What they found left them astounded. The ROV beamed back images of a vibrant coral reef ecosystem, a sight they never expected to see in such a dark and hostile environment. It was flourishing in the darkness of the deep sea, thriving in conditions that seemed impossible for coral life. This was completely unexpected. Corals typically rely on sunlight for photosynthesis, a process that allows them to convert light into energy. This is how they get their energy, by absorbing sunlight through their symbiotic relationship with algae. However, these corals were thriving in the absence of light, suggesting they had adapted to harness energy from the chemicals released by the hydrothermal vents. A remarkable adaptation that challenges our understanding of coral ecosystems. The discovery of this deep-sea coral reef sent shockwaves through the scientific community. It was an unexpected find, hidden in the depths of the ocean where sunlight barely penetrates. It challenged our understanding of coral biology, pushing scientists to rethink what they knew about these fascinating organisms. Corals are animals, not plants. They are complex creatures that form intricate colonies, creating the vibrant reefs we see. They belong to the same phylum as jellyfish and sea anemones known as Cnidaria, which are characterized by their stinging cells. They are known for their symbiotic relationship with algae, specifically zooxanthellae, which live within their tissues. These algae provide them with food through photosynthesis, converting sunlight into energy that the corals can use. Without sunlight, scientists were baffled as to how these deep-sea corals were surviving. The absence of light posed a significant mystery. They theorized that the corals must be relying on a different energy source, one that did not depend on sunlight. Further investigation revealed that the corals were hosting chemosynthetic bacteria. These bacteria convert inorganic molecules into organic matter, providing the corals with the necessary nutrients to thrive in such an extreme environment. Section 4. Thriving in darkness. Chemosynthesis is a process by which organisms convert chemicals into energy. This occurs in the absence of sunlight. The bacteria living within the deep-sea corals were using hydrogen sulfide. This is a chemical compound released from the hydrothermal vents. They were using it as an energy source. This discovery was groundbreaking. It demonstrated that coral reefs could exist in environments previously thought to be inhospitable to them. It also highlighted the incredible diversity of life in our oceans. Section 5. A delicate balance. The deep-sea coral reef is a delicate ecosystem, teeming with life and vibrant colors. These underwater gardens are home to a diverse array of marine species, each playing a crucial role in maintaining the balance of this fragile environment. However, this delicate balance is threatened by a number of factors including ocean acidification, pollution, and climate change. These threats are not just isolated incidents but are interconnected, creating a web of challenges that the coral reefs must face. Ocean acidification, for instance, is caused by the absorption of carbon dioxide from the atmosphere. As human activities increase the levels of CO2, the oceans absorb more of this gas. This process lowers the pH of seawater, making it more acidic. The increased acidity can have devastating effects on marine life, particularly on corals. The calcium carbonate skeletons of corals, which provide structure and support, begin to dissolve in more acidic conditions. This weakens the corals, making them more susceptible to disease and damage. Pollution from oil spills, plastic waste, and other human activities can also damage coral reefs. These pollutants can smother corals, block sunlight, and introduce toxins into the ecosystem. Climate change is leading to rising sea temperatures, which can cause coral bleaching. Warmer waters stress the corals, causing them to expel the symbiotic algae that live within their tissues. This is when corals expel the algae living in their tissues, turning them white. Without these algae, the corals lose their major source of food and their vibrant colors, leading to a weakened state and, eventually, death if conditions do not improve. Section 6. Unseen Wonders. The discovery of the deep-sea coral reef serves as a reminder of the vastness and mystery of our oceans. There are still countless species and ecosystems waiting to be discovered. It also highlights the importance of ocean exploration and research. By studying these underwater environments, we can gain a better understanding of the interconnectedness of life on Earth. We can also learn how to better protect our planet. Section 7. A call to action. The deep-sea coral reef is just one example of the many wonders that lie beneath the waves. It is our responsibility to protect these fragile ecosystems for future generations. We can all do our part by reducing our carbon footprint, supporting sustainable fishing practices, and advocating for ocean conservation. By working together, we can ensure that our oceans continue to thrive for centuries to come. Let us embrace the opportunity to explore, understand, and protect the underwater world.